VSEPR, or VSEPR, according to who you ask, is a way to figure out where atoms in a molecule fall into place. The idea that there is a correlation between molecular geometry and number of valence electrons was originally posed in 1939. This concept was revised and re-revised over some 20-odd years until it became what we know today. The basics of it state that pairs of electrons really want to stay as far away from each other as possible. An easy way to visualize this is to imagine two magnets of the same polarity tied to a fixed point with some string. The magnets are going to try their best to push each other away. The magnets, assuming they have infinite push against each other, will hover at an exact 180-degree angle. The name for this shape, unsurprisingly, is linear, because it forms a line. The same goes for three magnets hovering in a perfect triangle. Because it's one triangle on a plane, the shape is called trigonal planar. However, weirdness starts to happen when you introduce a fourth magnet, because suddenly a plane isn't the best way to organize the electrons. So it becomes this gross mess of 4 electrons in a central atom, but it makes more sense than it seems. This 4-electron mess can be broken up into 2 symmetrical sets of 2 electrons, this sort of bunny ears arrangement. And unless you know what a tetrahedron is, the name tetrahedral seems out of place and complicated, but don't worry, all it is a shape like this, with the electrons here. With 5 electrons, it just becomes a combination of 2 earlier ones, linear and trigonal planar. The rest of these just follow these patterns, but weirdness starts up again when we add non-bonding electron pairs. Because they take up more space, we can imagine them as stronger magnets, infinity plus 1. Of course, this means that anything with lone pairs acts differently than regular electrons. So this means if we have 2 bonded pairs and 1 non-bonded pair, we have a shape that isn't quite linear, but doesn't have any other classification either. The creative types name this shape bent, because it's bent. So the main takeaway from this is that electron pairs push really hard on each other, and lone pairs push a little bit harder. So it might just be easier to memorize the tough angles, but if you took Intro to Geometry, you know that the angles between the points of a triangle are all 120 degrees, and the angle of a line is 180 degrees, etc. The hard part comes in memorizing the non-planar ones, and unless you enjoy knowing that the edge central angle of a tetrahedron is exactly 109.4712 degrees, this might just be something you have to memorize. That being said, the ones you really have to know are linear, trigonal planar, tetrahedral, trigonal bipyramidal, octahedral, bent, and trigonal pyramidal. The first 5 are easy to remember, with maybe the exception of octahedral, because it sounds like there should be 8 electron pairs, but you need to remember that the naming is based on the 3D shape and not the number of pairs. The exact angles of the other 2 are tougher to remember, but once you get these down, you can find the angles of any other shape. So basically, it's not as hard as it seems, and if you can memorize 104.5 and 109.4, you can have this VSEPR thing down easy.